my YouTube channel. I'm Nwachukwu Daniel. Today we'll be discussing stoichiometry in chemistry. Please, if you have not subscribed to my YouTube channel, please don't forget to do so. It will not cost you anything. Okay? Now, back to the topic, stoichiometry in chemistry. Stoichiometry simply means a term or a word that tells us that there is a relationship between mass and volume of a substance. Yes, what do we mean by that? Stoichiometry helps us to see that there is a relationship between mass of substance A and mass of substance B. It helps us to also see that there is a relationship between mass of substance A and volume of substance B. It helps us to see that there is a relationship between volume of substance A and mass of substance B. It helps us to see that there is a relationship between volume of substance A and volume of substance B. What do we mean by all these grammars? Take for instance, assuming you want to take a coffee drink, a hot coffee drink, so to speak, and you take your spoon, or maybe you want to take a tea, you want to take your tea this morning, and you take your spoon and take 1 teaspoonful of that tea and put it inside your cup. Then you and I know that what you do is that you take half cup of hot water, or let's say 1 cup of hot water, small cup, and put it inside that tea. Then have a tasteful tea. Not so, that is good and that will be tasteful and sweet to our mouth. Then what if after putting, let's look at it in another way, you just put 1 teaspoonful of that, maybe chocolate, or maybe the Bonvita or Ovaltine, or maybe Milo. You put 1 teaspoonful of it inside your teacup, and you carry 1 full jug of hot water and pour inside it. Pour everything inside it. You and I know that the tea will be so watery. Not so? And because it is so watery, if I ask you as a science student or even an art student, why do you say that this tea is so watery and tasteless? You will say it's because the water is in excess. That brings to us that in that preparation, that the one of 1 full jug of hot water, we say that the excess reactant there is water. Then we also say that the tea is very small in that preparation. Not so? So the tea is the limiting reactant. In stoichiometry, you'll be hearing those words, limiting reactant, excess reactant. And I believe you appreciated it with this tea and full jug of hot water we'll talk about. So in that second scenario, the one of 1 teaspoonful of your chocolate or your Bonvita or your Milo or Ovaltine and 1 full jug of water, you'll see that your excess reactant will be the water and the tea is the limiting reactant. Let's appreciate this with the question we have on the board. Let's see how we can get our limiting reactant and our excess reactant from the question we have on the board. See the question. Strontium hydride 5.7 gram was made to react with 4.75 gram of water to form 6 gram of strontium hydroxide according to the reaction equation below. You see the equation of the reaction. How many grams of hydrogen can be formed from given mass of strontium hydride? How many grams of hydrogen can? So these are the questions we want to solve. Now, to solve it, before you solve a question on stoichiometry, please, you must use a well-balanced chemical equation to do so. If your equation of reaction is not balanced, please, you will not be able to solve it. So first step is that your equation of fraction must be well balanced. So we check strontium 1, hydrogen 6, oxygen 2, oxygen 2. Our equation is balanced. Now go to the question. The question says, how many grams of this can be formed from given mass of this? Now, write down the equation. You write it out. Plus water to give you strontium hydroxide plus hydrogen gas. So we just write it down. Now, you must get your formula mass before you solve this question. What do you mean by formula mass? Strontium is noted to be, the atomic mass of strontium is 89.62. 89.62 plus hydrogen is 2. That will be giving us what? Strontium is given to us as 89.62, and 9.62 plus 2 will be giving us 91. Please, strontium is 87.62. 87.62 plus 2. 87.62 plus 2 will give you 89.62 gram per mole. Now, 89.62 gram per mole times 1 mole here. You have 1 mole, 2 mole, 1 mole, 2 mole. So 89.62 gram per mole times 1 mole, that will be giving us 89.62 grams. So this is formula mass of this. Remember, strontium is given to us that the atomic mass is 87.62, so that you will not find it difficult. Then hydrogen. Hydrogen, the atomic mass is 1. 1 times 2, 2. Plus, this is atomic mass is 1. 1 times 2, 2. Plus oxygen is 16. Plus 16, that will be giving you 18. But then, this 18 times 2 will be giving you 36 grams. That is for water. Then for here, we have strontium to be 87.62 plus oxygen is 16, hydrogen is 1, 17. 17 times 2, 34. So we'll be having 34. So when you add this, it will be giving you 2612. So 121.62. We write it 121.62 gram. Why we say gram is that when you times this one here, it will be giving you in gram. That is formula mass. Here hydrogen is 1. 1 times 2, 2. 2 times 2, 4 grams. So these are the formula mass of this. Remember, the equation must be balanced, as you can see. Our own equation is very balanced, or well balanced. Now what you now do is that they say how many grams of hydrogen can be formed from given mass of strontium hydride. They say how many of these can be formed from this. We are comparing this and this. What you just do is that you write what is the formula mass of this. You say it's 9.62 grams because they say from strontium hydride. Then gives you 4 grams of hydrogen. This is 89.62 grams of strontium hydride. So this will give you this from our equation. Then what you now say is that what is the mass of strontium hydride that we use in the reactor? That is 5.7. We say 5.7 gram of strontium hydride will be giving us what? You cross multiply 5.7 times 4 all over 89.62. That will be giving you, this times is divided by this, will be giving you 0.254 grams. answer. But if they want the answer to be in mole, maybe they say, how many moles of hydrogen can be formed from this? You can also convert this to mole. This is already of hydrogen gas. You have gotten your answer in terms of gram. In terms of mole, you say, what is the molar mass of a hydrogen gas? Hydrogen gas will be 1 times 2. So you now say 0.254 all over 2. That will be giving you 0.127 moles. So this is the answer in gram, while this is the answer in moles of hydrogen. So we have solved question number 1. Want to solve question number 2? To solve it, they say, how many grams of hydrogen can be formed from given mass of water? It means compare this water to this hydrogen. Now, the water is 36 grams of water to give you 4 grams of hydrogen gas. But, yes. Now, how many water went into reaction? 4.7 gram, because they say react with 4.7 gram of water. 4.7 grams of water went into reaction to give us what? You cross multiply. It will be 4.75 times 4 all over 36. And when you cross multiply, this times is divided by this will be giving us 0.53 grams. Then, this is grams of hydrogen formed from water. What is the amount in moles? Hydrogen, the atomic mass of it, or molar mass of it, is 1 times 2. So, we say that molecular mass of this hydrogen gas is 2. So, you now say 0.53 all over 2. That will be giving you 0.26 moles. 0.26 mole of hydrogen. So this means that 0.5 gram of hydrogen is equivalent to 0.26 mole of hydrogen. And that is what is formed from the water we have in the equation. Now the next one says, what is the limiting and excess reactant? That means in this reaction, one is in excess and one is limited. What do we mean? Go to the reactant side of your equation. Only consider your reactant side of your equation. You see that it's 9.62 grams of strontium hydride reacted with 36 grams of water. It reacted with 36 grams of water. The implication of it is that since they say 5.7 gram was made to react with 4.7 gram of water, that is, strontium hydride was 5.7 gram in the equation, then the water is 4.7 gram. The implication is that since our equation or our relationship is very correct, if we say 5.7 gram of strontium reacting, it means that for us to say that this reaction we have here is very correct, for us to say that this reaction that the producer did or that the manufacturer did is very correct, we must get 4.7 gram of water, because he reacted this with this. Remember, I said you must use this relationship we got from our well-balanced equation, which says that 9.62 gram of this reacted with this from our equation. That means if 5.7 gram of this goes into reaction, after cross multiplying, that is 5.7 times 36 all over 89.62, and we get 4.75 grams of water. The implication is that this reaction is very correct. But if we do our cross multiplication, 5.7 times 36 all over 89.62, and it's giving us an answer less than 4.75 grams of water. If after your cross multiplication this times is divided by the, and it's giving you an answer that is less than 4.75, a value that is, let's say it gives you 3. The implication is that the water we use here is in excess. If this cross multiplication gives you less than this, the implication is that the quantity of water we use is very excess. Take for instance, after cross multiplying, let's say we got 3. For instance, 3 is less than 4.75. For instance, I say let's take it that after cross multiplying we got 3. The implication is that the quantity of water we use exceeded the actual quantity we're supposed to use. Here, water will be excess. Water equal to excess. Then strontium hydride equal to limited. But if after we cross multiply 5.7 times 36 all over 89.62, and it gave us an answer greater than 4.75 grams of water. If after our cross multiplication we got, let's say, 6, after cross multiplication, let's take for instance, after cross multiplication we get 6. 6 is greater than 4.75. Not so. It simply means that if we get 6 after our cross multiplication, it means that the quantity of water we use is smaller than the actual quantity we're supposed to use. And because the quantity of water is smaller than the actual quantity we're supposed to use, we say that water equal to limited. That is limiting reactant. Then strontium hydride equal to excess. That is what we mean. Okay, we now compare this to this, the reactant side. We now say 89.62 grams of this reacted with this. Then the 5.7 grams of strontium hydride should react with what? We now say 5.7 times 36 all over 89.62. That will be giving us 2.29 grams of water. 2.29 grams of water. Now the question is, 2.29 grams of water, is it less than 4.75 that went into reaction? Or is it greater than 4.75 that went into reaction? It falls here, where it is less than this. Now because 2.29 grams of water that we got that should react with this is less than this, it means that the water we use, that is 4.75, is in excess and strontium hydride is limited. So we now say it supports this. This our answer supports this. We now claim to write our main answer. We now say, since this gave us 2.29 grams of water, it means that the manufacturer who used 4.7 grams of water in the reaction, he made a mistake. He's supposed to use this 2.29. So he used excess of water, then the limiting reactant, limiting equal to strontium hydride. So what this tells us is that the quantity of water the manufacturer used is excess, more than reactant is strontium hydride. We say strontium hydride is 89.62 grams. Okay? To produce 4 grams of hydrogen gas. So it is this strontium hydride that will produce this. Then what will happen now is that you say, what amount of strontium hydride went to reaction? 4.7 grams of strontium hydride will give us, once you react it, this times this divided by this, it will give you the answer in grams. So it will give you these grams of hydrogen. Okay? And this gram of hydrogen, we have even gotten it. It will be giving us 0.254 grams of hydrogen if you press it in your calculator. Okay? Then, to get it in moles, because they say we should get the volume, it means that we have to convert this in mole. What is the molecular mass of hydrogen? Atomic mass of hydrogen is 1 times 2. This divided by 2, that will be giving you 0.127 mole of hydrogen gas. Now, since we have this to be the moles of hydrogen produced, we now remember that at STP, that 1 mole of a gas is equal to 22.4 dm cube. So you now say 0.127 mole of the gas of the hydrogen will be giving you cross multiply 0.127 times 22.4. So when you cross multiply it, it will be giving you that will be giving us 2.845 dm cube of hydrogen gas. So this is the volume of the hydrogen produced at STP. We now go to the next question and say, what mass of strontium hydroxide is produced? Now, remember, we must also use our limiting reactant. Only your limiting reactant that you use to get the volume of the product or the amount of the product or the mass of the product produced. Now, you now say your limiting reactant is 89.62 grams of strontium hydride. You say it produces 161.62 grams of strontium hydroxide from the equation. Then you now say the 5.7 grams of strontium hydride that went into reaction will be giving you cross multiply 5.7 times 121.62 all over 89.62. So when you cross multiply it, you'll be having 7.74 grams of strontium hydroxide. So this amount of strontium hydroxide is the amount that is produced in the reaction. Then this is what we call our theoretical yield. Call it your because you produce it from your reaction. Then we go to the last question. What is the percentage yield of strontium hydroxide in the reaction? Remember in the question they said that the strontium hydride was made to react with this of water to form 6 grams of strontium hydroxide. So the 6 grams of strontium hydroxide is the actual yield. Now we say percentage yield has this formula. Actual yield over theoretical yield times 100% over 1. So the actual yield is the one given to you in the question. So they say to form 6 grams of sodium hydride. So you now say 6 grams all over the theoretical yield we have 7.74 times 100 over 1. So that will be giving us 7.5%. That is your percentage yield. Note that your percentage yield should be less than 100%. Okay? So if the percentage yield is more than 100%, it's not a good reaction. So it should be less than 100%. That is, the theoretical yield should be more than the actual yield. Percentage yield should be less than 100%. As you can see, our own is less than 100%. That is some 7.5%. Thank you for watching the video. Please don't forget to click subscribe and turn on your notification button.